Let's move on now to airborne sound transmission. Sound transmission loss is the decrease in sound energy, expressed in decibels of airborne sound, as it passes through a building construction. The metric used to quantify that reduction is the Sound Transmission Classification, STC. The STC value indicates how well sound is controlled room to room, including through walls or through floor-ceiling assemblies. ASTM E90 is the standard covering airborne sound transmission class, or STC. This is a single number rating that evaluates the efficiency of systems in reducing the transmission of airborne noise. In this class, the higher the STC rating, the better. The rule of thumb is that a 10-point increase in STC means a decrease in the perceived noise by 1/2. Let's look at how to control sounds through several kinds of walls and floor-ceiling assemblies. We'll look at steel stud partition walls, wood stud partition walls, wood joist floor-ceiling assemblies, metal buildings, and lightweight concrete floating floors. Steel stud partition walls. Here's a fact. Light-gauge steel studs, typically used in walls, are acoustically resilient, so they, by themselves, reduce some sound energy transmission compared to concrete or wood. However, air sealing always improves sound control regardless of the structure involved. And by adding sound-absorbing cavity insulation to a steel-framed wall, you will greatly improve the sound performance of that assembly. For example, you'll get a similar increase in acoustical performance if you either double the drywall or you keep a single layer of drywall on each side and add insulation. So drywall plus fiberglass insulation is the cost-effective option. Here's the data, comparing 3 steel stud partition walls. Wall 1, standard construction, has an STC of 38. Steel wall 2 with a double layer of drywall, no cavity insulation, air sealed, has an STC of 50, a substantial improvement. But wall 3 also has an STC of 50 and is the most cost-effective. It has a single layer of drywall, fiberglass insulation in the cavity, and is air sealed. Let's look at wood stud partition walls. As opposed to steel, wood studs are acoustically stiff. Sound transmits readily through wood. First, air sealing improves sound control. Then, by adding cavity insulation, we use fiberglass as our example, the STC is improved 2 to 3 points. Now, you'll achieve a significant increase in acoustical performance by mounting drywall to resilient channel and adding sound-absorbing cavity insulation, as you see here in the improved wall illustration. Here's the data for 3 wall constructions. Wood 1 is a standard wood-framed wall, 2x4, 16 inches on center, and no cavity insulation, and no air seal. The STC for that assembly is 29. Wood 2. If we take that assembly and we make it airtight and we add cavity insulation, the STC increases by 10 to 39. Wood 3. We've added cavity insulation, mounted the drywall to resilient channel, and air sealed with a sealant. Now this is a dramatic improvement in STC with a value of 46. We're looking at airborne sound transmission through wood joist floor ceiling systems. Remember, the wood joists are acoustically stiff, easily transmit sound. So air sealing does improve sound control to a point. Wood ceiling joists have more mass and are deeper than wood wall studs. So adding cavity insulation to this space limits the improvement to 1 to 2 points because of the inherent qualities of wood construction. Where you get a really significant increase in acoustical performance is when you use sound-absorbing cavity insulation and you break the structural tie between the ceiling and the framing system with resilient channel or by using hanger wire. Here are 5 wood joist floor ceiling assemblies for comparison. Floor 1, standard construction, air sealed, STC 33. Floor 2, achieves STC 34 by adding fiberglass insulation 6 1/4 inches thick. Floor 3 eliminates the cavity insulation and instead adds drywall mounted to resilient channel, breaking the structural tie for STC 43. Floor 4 achieves STC 52 by adding in the fiberglass insulation. Good score. And floor 5, the highest value, STC 54. This floor includes the fiberglass and a wire-suspended drywall ceiling for the best acoustical treatment and a 19-point improvement over standard construction. Metal buildings present another challenge for sound control, and a variety of acoustical treatments with fiberglass insulation are available, resulting in STCs ranging from 28 to as much as 54. Data is available through the North American Insulation Manufacturers Association. Again, breaking the structural tie and adding specialized metal building insulation will create maximum benefits, and there are several options.